Welcome to this explainer. Today, we're jumping right into the sheer scale of the largest land animals in Earth's history. You know, it's funny, when we think of dinosaurs, we automatically think massive, even though some of them were actually smaller than modern-day chickens. But today, we're focusing on the absolute heaviest of the heavyweights, and we're going to unravel the incredibly complex science of how we actually weigh an extinct titan.
Just look at the brilliant sense of scale here. That is a single backbone from an Argentinosaurus right next to a human hand. I mean, it immediately shows us we're dealing with animals of almost unfathomable proportions. When just one piece of your spine is taller than a grown adult, the normal physical rules of how a body operates, they kind of have to change completely.
Section 1. The True Heavyweights, Late Cretaceous Giants.
Okay, 73 tons. Let that number sink in for a second. This mind-boggling figure is the most widely accepted estimated weight of Argentinosaurus. We are talking about an animal that measured over 100 feet long. Now, you'll sometimes see estimates pushing up to 80 or even 90 tons, but through rigorous math focusing on the femur and vertebrae, 73 tons is our most solid baseline for this behemoth.
And the crazy thing is, it wasn't alone. Check out Patagotitan mayrum. Discovered back in 2014, this incredible sauropod stretched 122 feet in length and weighed in at roughly 70 tons. To put that into everyday perspective, that is the equivalent of 10 modern African elephants combined.
Now, as this chart shows, while these titanosaurs were absolute land behemoths, they still maxed out at about half the weight of today's blue whale, which can easily tip the scales past 150 tons. For the longest time, scientists assumed you absolutely needed ocean buoyancy, floating in water, to ever surpass that 100-ton mark. But hold on to that thought, because we're going to come back to it.
Section 2. Math, Models, and Missing Bones. So here is the multi-million-dollar question. How do you actually weigh an animal that hasn't existed for 70 million years? Especially when you almost never find a perfectly complete skeleton. It's like a giant puzzle. This brings us to a massive scientific debate highlighted in this research paper about a dinosaur named Dreadnoughtus. When it was first discovered, they estimated it weighed a staggering 59 tons. But soon after, that number got totally upended. You see, paleontologists basically use two competing methods to weigh these prehistoric ghosts. On the left, you've got scaling equations. This estimates mass based on the circumference of the leg bones. Basically, how thick are the pillars holding up the animal. On the right is volumetric modeling. This is where they take 3D laser scans and wrap a virtual skin, a convex hull, over the skeleton to calculate the volume.
Well, when scientists applied that 3D volumetric modeling to Dreadnoughtus, they realized the original scaling equations were, frankly, way off. To actually hit that 59-ton estimate, the virtual model would have needed an impossible amount of soft tissue expansion outside the skeleton. We're talking beyond what any living four-legged mammal has today. So they effectively downsized the giant to somewhere between 37 and 64% of its original estimated mass. It really just goes to show how tricky this science can be.
Section 3. The Lost Titans.
Let's shift gears and head over to India for a fascinating, if not totally frustrating, discovery. Meet Bryhadkayasaurus. The name literally translates to huge-bodied lizard. Now, this dinosaur is known from incredibly fragmentary remains found in 1978. But what they did find was staggering. A supposed shin bone measuring an astonishing 6.6 feet long. That is nearly 30% larger than the equivalent bone in the already massive Argentinosaurus.
170 tons. No, seriously, if you take that massive bone and geometrically scale it up using our best models, some estimates suggest this animal could have weighed between 110 and 170 tons. Researchers literally refer to these theoretical creatures as land whales. At 170 tons, it wouldn't just be the largest dinosaur, it would actually rival the largest blue whale ever recorded.
But here is the heartbreaking reality of paleontology. We will probably never know for sure. Thanks to harsh monsoon rains in India, these massive waterlogged fossils literally disintegrated. They crumbled into dust inside their protective field jackets. Before they could even be preserved, the physical evidence, it just no longer exists.
Section 4. Engineering a giant. So, knowing the immense scale of these creatures, even if we just stick to the conservative 70-ton estimates, how did they walk without their bones just shattering under the sheer force of gravity? Well, sauropods evolved a brilliant suite of biological engineering. They had long static necks to sweep up vegetation without burning energy moving around.
They didn't chew, which meant super fast energy intake. And fun fact, since their closest living relatives are actually birds and crocodilians, they shared these amazing bird-like internal air sacs that significantly reduced their overall body density.
But the real secret weapon was in their feet. This beautifully illustrates a crucial evolutionary upgrade, the development of a soft tissue foot pad that showed up as early as the late Triassic period. Using computer modeling, called finite element analysis, which is literally the same software engineers use to test airplanes and bridges, scientists proved something amazing. They found that without a soft tissue pad, a 70-ton dinosaur's bones would experience catastrophic stress beyond their physical limits. They physically required a shock-absorbing heel pad, a lot like modern elephants have, just to survive standing up.
And this structure worked perfectly. As the foot slammed into the ground, that heel pad absorbed the massive initial impact. Then it redistributed all that pressure evenly across a huge, flat surface. This allowed the upright skeletal bones inside the foot to maintain a tiptoe posture, keeping the bone stress safely within the limits of physics. It is an absolute masterclass in biomechanics.
Which brings us to a truly humbling question. Knowing that giants like Bruchothiasaurus have already crumbled to dust, is the absolute limit for terrestrial life still waiting out there to be discovered? Or has it already washed away in the rain millions of years ago? Think about that the next time you're looking at a fossil. Thanks for hanging out with me for this explainer, and keep questioning the world around you.